Imagine this. You're sitting right where you are now, reading this, breathing, living your normal life, and then the sun just vanishes, gone, in an instant. But here's the thing that'll blow your mind. You wouldn't even know it happened. Not for over 8 minutes. And when you finally did realize, the nightmare that follows isn't what you think. It's so much worse. Stick with me, because what I'm about to tell you will change how you see our entire existence. And I promise, by the end of this, you'll never look at the sky the same way again. Okay, so let's get one thing straight right off the bat. This isn't some Hollywood disaster movie where everything explodes and people are running around screaming immediately. No, reality is far more terrifying because it's slow, it's methodical, and it's absolutely inevitable. The sun disappearing isn't just about losing light. It's not just about getting cold. It's about losing the very anchor that holds our entire solar system together. It's about physics turning against us in ways that would make your head spin. So what would really happen? Let's break this down minute by minute, hour by hour, day by day. And I'm warning you now, this gets dark, literally and figuratively. Here's something wild that most people don't know. Light from the sun takes about 8 minutes and 20 seconds to reach Earth. It travels at 186,000 miles per second, the fastest speed possible in our universe. And even at that insane speed, it still takes over 8 minutes to get here. So if the sun disappeared right now, and I mean right now, we'd still see it shining in the sky for another 8 minutes. The birds would still be chirping. The plants would still be photosynthesizing. Everything would seem perfectly normal. But here's where it gets interesting. Gravity also travels at the speed of light. That means Earth would keep orbiting exactly where the sun used to be for those same 8 minutes. We'd be circling around nothing, and we wouldn't even know it. Think about that for a second. For 8 whole minutes, humanity would be living in a world that's already doomed, and we'd have no idea. Kids would be playing, people would be working, you might be making dinner, and all the while we're already dead. We just don't know it yet. It's like that moment in a cartoon where a character runs off a cliff but doesn't fall until they look down. Except this is real, and there's no coming back from this fall. And then, it happens. The sky doesn't gradually dim like a sunset. There's no twilight. 1 second the sun is there, and the next second, darkness. Complete, absolute, total darkness. Now I want you to really imagine this. Not nighttime darkness where you have the moon and stars. I'm talking about a darkness so complete that you can't see your hand in front of your face. Why? Because the moon doesn't produce its own light. It reflects sunlight. No sun means no moonlight. And while there would still be stars, they're so far away they'd barely provide any light at all. The immediate reaction? Panic. Pure, absolute panic. People would stumble. Car accidents would multiply instantly as headlights become the only source of light on the roads. Power grids would be overwhelmed as everyone tries to turn on every light in their house. Social media would explode with confusion and terror. But you know what? That panic would be nothing compared to what comes next. Remember how I said gravity travels at the speed of light? Well, at the 8-minute 20-second mark, something else happens that's absolutely mind-bending. Earth stops orbiting. We're cruising through space at about 67,000 miles per hour in our orbit around the sun. But the sun's gravity is what keeps us in that orbit. It's like spinning a ball on a string. The string provides the tension that keeps the ball going in a circle. Cut the string, and the ball flies off in a straight line. That's exactly what would happen to Earth. We'd shoot off into space in whatever direction we were traveling at that exact moment. Just flying through the void in a straight line, getting further and further from where the sun used to be. Now, you might think, great, we'd just drift into deep space. But hold on, it gets more complicated. Every other planet would do the same thing. Mars, Venus, Jupiter, Saturn. All of them would suddenly break free from their orbits and start flying off in different directions. And here's the terrifying part. We could potentially collide with one of them. The chances are actually pretty low because space is really big. But it's not zero. Imagine a cosmic game of pinball where the balls are planets, and there's no way to predict where they'll go. And Earth isn't alone in its orbit. We have the moon, that 2,000-mile-wide ball of rock that's been orbiting us for billions of years. It would keep orbiting us because our gravity would still hold it. Small comfort, but at least we'd have company as we drift into the eternal void. Okay, so we're in complete darkness. We're flying through space, and now, It's time to talk about the cold. The Earth's average temperature is about 59 degrees Fahrenheit. That's thanks to the sun constantly bombarding us with energy. But with the sun gone, that energy stops coming. However, Earth wouldn't freeze instantly. This isn't like stepping into a freezer. Space is actually an incredible insulator because it's mostly a vacuum, and heat needs matter to transfer quickly. So the heat we do have would take time to radiate away. Within the first 24 hours, the temperature would drop noticeably but not catastrophically. We'd probably lose about 10 to 15 degrees Fahrenheit. That might not sound like much, but it's just the beginning. The real problem starts with photosynthesis stopping immediately. Every plant on Earth depends on sunlight to convert carbon dioxide into oxygen and sugar. Without sunlight, every single plant would start dying within days. Think about that. The bottom of the entire food chain would collapse almost instantly. No more grass for herbivores. No more crops for humans. The green living world would start turning brown and dead faster than you could imagine. But humans? We'd be okay for a while. We have electricity. We have stored food. We have heating systems. The first day would be scary but survivable. It's what comes after that should terrify you. By the end of week 1, the average temperature on Earth would have dropped to around freezing, 32 degrees Fahrenheit. But it wouldn't be uniform. Areas near the equator might still be above freezing, while the poles would be absolutely brutal. Power grids would be under massive strain. Everyone would be running heaters constantly. Governments would declare states of emergency. The panic buying would be unlike anything we've ever seen. Food, batteries, fuel, blankets, everything would be stripped from stores within hours. And here's where human nature shows its ugly side. When resources become scarce and the future looks hopeless, civilization gets thin really fast. We'd see looting, violence, a breakdown of social order in many places. But some areas would band together. Communities would pool resources. Scientists and world leaders would be working around the clock to figure out solutions. Because humanity is nothing if not stubborn. We'd be searching for any possible way to survive. The oceans, though? The oceans would be our temporary savior. Water retains heat incredibly well. The ocean's top layer would start to freeze, but the deeper you go, the warmer it would stay for quite a while. Marine life in the deep ocean might actually survive longer than anything on land. Here's where things get really, really bad. As the Earth continues to cool, something catastrophic starts happening to our atmosphere. Air is made up of gases, and gases contract when they get cold, really cold, at around -40 degrees Fahrenheit, which we'd hit after about 2 weeks. The first parts of our atmosphere would start to literally fall out of the sky. Water vapor would be first. Every bit of humidity in the air would freeze and fall as snow. We're talking about a global snowstorm that would last for days, covering everything in a layer of ice crystals. Then carbon dioxide would start to freeze. It becomes dry ice at -109 degrees Fahrenheit. You'd see CO2 snow falling from the sky, coating everything in a layer of frozen carbon dioxide. The air itself would become thinner as it contracts and pools in the lowest areas. Breathing would become harder, especially at high altitudes. Mountains would become death zones even faster than they are now. By this point, anything living on the surface would be in serious trouble. Humans in heated bunkers with oxygen supplies might make it, but everyone else? The odds would not be good. After about a month, we'd hit -100 degrees Fahrenheit on average. The oceans would have a thick layer of ice on top, several feet thick in some places. But underneath, there'd still be liquid water. This is actually important. If humans were going to survive long-term, it would be in underground facilities near geothermal vents or in submarines under the ice. Places where we could tap into Earth's internal heat. Because here's something people forget. Earth has its own heat source that has nothing to do with the sun. The core of our planet is about 10,800 degrees Fahrenheit, heated by radioactive decay and leftover heat from when the planet formed. That heat would still be there. Geothermal energy would become humanity's only real power source. Places like Iceland, with their geothermal plants, would become the most valuable real estate on Earth. Deep underground facilities could potentially maintain livable temperatures indefinitely, but we're talking about a fraction of humanity surviving. Maybe a few 100,000 people at most, all living in carefully controlled environments. The rest, gone. The plants would all be dead or dying. The animals would have no food. The entire surface ecosystem would collapse. It would be the fastest, most complete mass extinction event in Earth's history. Fast forward to 1 year after the sun disappeared. The average temperature on Earth would be around -400 degrees Fahrenheit. At these temperatures, even nitrogen, which makes up 78% of our atmosphere, would start to freeze. It becomes liquid at -320 degrees and solid at -346 degrees. Our atmosphere would literally be falling out of the sky and piling up on the ground as frozen layers of nitrogen ice. The oceans would be frozen solid hundreds of feet deep. Only the deepest parts of the ocean, where the pressure is immense and geothermal vents provide heat, would still have liquid water. Earth would look like a completely alien world. A frozen ball of ice covered in layers of frozen air, lit only by starlight. The only light sources would be human-made, the lights of whatever underground bunkers or facilities were still running. And those humans? They'd be living an existence that would make a submarine crew's life look comfortable. Recycled air, recycled water, rationed food from whatever we'd managed to grow in artificial light. Every single resource would be precious beyond measure. The psychological toll would be immense. Imagine never seeing natural sunlight again, never feeling warmth on your face, never seeing a blue sky or a green tree or feeling rain. Just endless artificial light in metal corridors, knowing that above you is a frozen hell that would kill you in seconds. Let's jump ahead. 10 years have passed since the sun vanished. Where is Earth now? We'd be somewhere between 6 and 7 trillion miles away from where we started. For reference, the nearest star to our old solar system, Proxima Centauri, is about 25 trillion miles away. We'd be roughly a quarter of the way to the nearest star, just drifting through the void. But here's the thing. We probably wouldn't be heading toward any star. Space is mostly empty. The odds of us randomly drifting toward another star system are astronomically low. We'd most likely be heading into the space between stars, the deep, dark, cold emptiness that makes up most of the universe. Earth's core would still be hot. It takes billions of years for a planet's core to cool down completely. So geothermal energy would still work. Small pockets of humanity could theoretically still survive, powered by Earth's internal heat. But that survival would be tenuous. Equipment breaks down, resources run out, and the psychological strain of knowing you're on a frozen rock hurtling through space with no hope of rescue, that would break even the strongest minds eventually. There's actually a small chance, incredibly small, but not zero, that we could get captured by another star's gravity if we happened to pass close enough to one. We'd basically become a rogue planet that got adopted by a new solar system. But the odds of that happening in any reasonable time frame? Essentially zero. We'd be wandering the galaxy for millions of years before we'd have even a small chance of encountering another star. A century after the sun disappeared, Earth would have reached its final equilibrium temperature, around -455 degrees Fahrenheit. That's only about 5 degrees above absolute zero, the coldest temperature physically possible. Our atmosphere would be completely frozen on the surface. Layers of nitrogen ice, oxygen ice, even the tiny amounts of trace gases, all frozen solid. The oceans would be frozen to the bottom except for the deepest trenches. And humans, if any survived this long, they'd be living in incredibly advanced underground facilities, completely isolated from the surface. They'd be like the last embers of a fire that's almost gone out, hanging on, but barely. The most likely scenario for human survival would involve building a self-sustaining underground biosphere. We'd need nuclear or geothermal power to keep the lights on, artificial grow labs for food production, water recycling systems, air recycling systems, manufacturing capabilities to make replacement parts, Basically, we'd need to create a completely artificial world underground. And even then, it would be a constant struggle against entropy. Eventually, something critical would break that we couldn't fix, and that would be it. Okay, let's get real for a minute. Could humanity actually survive the sun disappearing? Technically, yes, but realistically, probably not for long. Here's why. We'd need to 1. React immediately. Start building underground facilities within hours of the sun disappearing. 2. Organize globally. No time for countries to fight over resources. 3. Gather resources. Stockpile everything we'd need for decades. 4. Preserve knowledge. Make sure we don't lose the technology and know-how to maintain our systems. 5. Maintain equipment. Keep everything running perfectly forever with limited resources. That last point is the killer. In our world today, we rely on global supply chains. Need a specialized computer chip? It might come from Taiwan. Need a specific chemical? It might be made in Germany. Need rare earth metals? They might be mined in China. All of that goes away when the sun disappears. You're stuck with whatever you have. And when that breaks, and it will break eventually, you can't replace it unless you have the means to manufacture it yourself. A few thousand people might make it a few decades. Maybe a few hundred could last a century if they're really lucky and really prepared. But beyond that, the odds drop dramatically. Believe it or not, there would be a few weird positives to this apocalypse. First, we'd have the most incredible view of the stars. With no sunlight and no atmosphere to scatter light, the night sky would be absolutely spectacular. The Milky Way would be visible in stunning detail. Distant galaxies would be visible to the naked eye. It would be hauntingly beautiful. Second, auroras would still occur. Earth's magnetic field would still be there, and solar wind from other stars or cosmic rays would still interact with any remaining atmosphere. We'd see incredible light shows in whatever thin atmosphere remained. Third, and this is wild, bacteria and microbial life in Earth's crust would probably be fine. There are microorganisms living miles underground that don't depend on sunlight at all. They live off chemical energy from rocks. Those little guys would outlive us all. Finally, Earth's core would stay hot for billions of years. So in theory, if intelligent life evolved again from those deep Earth microbes over millions of years, they could inherit a warm core and geothermal energy. They'd evolve in complete darkness, never knowing what a sun is, but they'd have energy to work with. Here's where we get deep for a minute. This whole scenario really drives home how fragile we are. We're living on a tiny rock, heated by a giant ball of nuclear fire, protected by a thin layer of gases, and we take it all for granted. Every breath you take, every meal you eat, every moment you exist, it's all possible because we're at exactly the right distance from a star that's exactly the right size, at exactly the right point in its life cycle. Move Earth a little closer to the sun, we'd cook. Move us a little further, we'd freeze. Make the sun a little bigger, it would burn out too fast. Make it smaller, not enough heat. We're in what scientists call the Goldilocks zone. Not too hot, not too cold, but just right. And we're only here because of an incredible series of cosmic accidents that happened over billions of years. The sun disappearing would remind us of something we often forget. We're not separate from nature. We are nature. We're made of star stuff, living on a rock, orbiting a star, in a galaxy full of other stars, in a universe we barely understand. And that should make every day you wake up and see sunlight feel like the miracle it actually is. Okay, real talk. The sun can't just disappear. It's not physically possible. Stars don't vanish. They can't. Matter and energy can't just cease to exist according to the laws of physics. The sun could explode, it could collapse into a black hole, though our sun isn't big enough for that, or it could just burn out slowly over billions of years. But it can't just vanish. But here's what could happen that would have similar effects. The sun will eventually run out of hydrogen fuel. When it does, it'll expand into a red giant, swallow Mercury and Venus, and possibly Earth too. Then it'll shed its outer layers and become a white dwarf. Same end result, no more sunlight, but it takes billions of years. If a black hole passed through our solar system, it could disrupt orbits and potentially eject Earth. We'd go flying off into space, still intact, but no longer orbiting the sun. This is the closest real scenario to what we've been discussing. A massive object, say a planet-sized body, could theoretically position itself between Earth and the sun. we'd be in permanent eclipse. The effects would be similar, but not quite as extreme since the sun's gravity would still be there. The sun could theoretically experience a dramatic decrease in activity. It's happened to other stars. We'd still have light, but less heat. It wouldn't be instant death, but it would be bad news for climate and crops. None of these are likely to happen anytime soon. The sun is a pretty stable middle-aged star. It's got about 5 billion years of good life left in it. Humans will be long gone before the sun becomes a threat. You know what's scarier than the sun disappearing? Things that could actually happen. Climate change. We're actively making our planet harder to live on. Asteroid impacts. Happened before, will happen again. Supervolcanoes. Yellowstone could blow anytime. Pandemics. COVID was a wake-up call. Nuclear war. Still have enough nukes to end civilization. AI going wrong. We're building something we don't fully understand. These are the real threats. Not hypothetical cosmic events, but things we have to deal with in our lifetimes. The good news? Unlike the sun disappearing, we can actually do something about these threats. We can reduce emissions. We can track asteroids. We can prepare for disasters. We can be smart about technology development. So why did I take you through this nightmare scenario? Why spend all this time talking about something that can't happen? Because it's a reminder that everything we have, our civilization, our technology, our comfortable lives, it all rests on a foundation that we can't control. We're passengers on a rock, heated by a star, in a universe that doesn't care if we live or die. But that's not depressing. It's empowering. We can't control the sun, but we can control how we treat this planet. We can control how we treat each other. We can control whether we work together or tear ourselves apart. The sun could keep shining for another 5 billion years, but if we destroy ourselves in the next 100 years through war or environmental collapse, it won't matter. The sun will still be there, shining on a dead world that used to be home to something beautiful. Every morning when you wake up, the sun is still there, still burning, still keeping us alive, still giving us another chance to get it right. Don't waste it. Here's the last thing I want to leave you with, something that'll mess with your head. Right now, you're on a ball of rock traveling through space at 67,000 miles per hour. You're spinning at 1,000 miles per hour because Earth rotates. The sun that's keeping you alive is 93 million miles away and is so big that 1 million Earths could fit inside it. That sun is one of 200 to 400 billion stars in our galaxy. And our galaxy is one of 2 trillion galaxies in the observable universe. And somehow, against all those odds, you're here, reading this, thinking, experiencing consciousness, living on the one planet we know of that can support life at exactly the right distance from exactly the right star. The sun disappearing would be the end of everything we know. But the sun not disappearing? That's the miracle we're living right now. So tonight, if you get the chance, go outside and look up at the sky. See that big ball of fire? Say thank you. Because without it, literally nothing else matters. And tomorrow morning, when you wake up and see sunlight coming through your window, remember, you just witnessed another small miracle. Another day where the sun rose, Earth kept spinning, and you got another chance to be alive. What are you going to do with it? If you like this video, to like and subscribe.